Good morning, ladies and gentlemen. You're here with Nhlanhla Maluleke, Nanomedicine Ambassador at Nabio Consulting. I'll be giving a small talk on nanomedicine. When you hear nanomedicine, you're thinking medicine, but then what's with the whole nano part? Okay, let's not take any shortcuts. Let's start from the bottom of all this. There was a scientist, a physicist to be specific, a very interesting man by the name of Richard Feynman, who wrote a letter. There's plenty room at the bottom. Yeah, you might be like wondering, what was that all about per se? So this letter was meant to inspire, or in our language today, it was to influence people or influence researchers and allow them or push them to engage in scientific research, which was specifically to look at the use of very small uh, um, particles instead of only looking at things that we can see with our eyes. So now, Richard Feynman had an idea or a thought, like, what if we could put all the words that are in an encyclopedia on, on the tip of a needle? Write everything that's in the encyclopedia on the tip of a needle. That was like something like a far-fetched idea if you were to say it in his time. But then this idea gave rise to much research around developing very small functional structures. We know we've heard about microchips, and now we've heard about nanochips. A whole lot of different scientific discoveries. So, nanotechnology. When we think nanotechnology, a tennis ball is something that can fit within one's hand. Now, if we could like zoom out and think of this tennis ball as something rather very small. Now, something that is so small that it's not naked to the human eye, so small that it's actually we have to actually use a microscope to view it. Now we're talking about something that is on a nanoscale. This tennis ball, as you can see in this image, it is actually a billion times bigger than a nanoparticle or the nanoscale that we're talking about. So nanotechnology basically is us manipulating matter on a nanoscale. Nanotechnology has multiple applications. It has found much great interest in different fields of study, in electronics, in energy and storage, and also in agriculture and foods. But then today, we'll only be focusing on something of much greater interest. Recently, with many advances such as um, different scientific studies around medicine development, such as therapy for cancer, therapy for HIV, and vaccines. Nanomedicine has gained much attention and is now being studied greatly in order to improve on these and different therapeutic measures, medicines, and vaccines. Now, nanotechnology or nanomedicine, it is applicable in diagnostics, in therapeutics, immunizations, and also vaccine production. Now, when we think of nanomedicine, the greatest thing that comes with nanomedicine is drug delivery systems. Now, the drug delivery systems are actually simple things to understand. We're looking at the manipulation or the modification of the nanoparticles in order for them to actually deliver a specific drug to a specific area within the human body. If we look at structures such as your antibodies, The antibody only binds to a specific target. It doesn't just bind to any random thing on the way. So when we talk about antibodies, we know that this nanoparticle will only bind to a specific site within the human body, and as such. So if we look at our nanoparticle, we put these structures, and these structures allow it to bind to specific sites, specific cells, and only interact with specific structures within the human body. And hence, these delivery systems, they allow us a great deal of opportunities. Now, this targeted drug delivery has allowed us to improve on immunotherapy, HIV therapy, and immunization, also in vaccine development. It has advantages in that we can it actually reduces the possibility of side effects, and we can actually control the dosage that we give to a patient. We can also control the drug release. Instead of having the drug released all at once it gets into the human body, we can actually have the drug being released in small doses at a time. So now it is also applicable in diagnostics. So when we talk about diagnostics, we're talking about our diagnostic kits, the different diagnostic kits that are used to detect viruses within our human bodies. Think of a common diagnostic kit, that simple, very small HIV test kit. It uses biological material in order to detect the virus, if it's there or not. So now with the application of our nanoparticles, we can actually be able for the first time to detect our viruses, even if there's only a very small amount of it within our systems. So these advances that comes with nanomedicine are so great that many scientists are actually moving or finding greater interest in this field of study. Thank you.